Today's session, Stormwater School, as always, is all about our attenuation and soakaway tanks. And the first being our main topic that we've got Lisa in the hot seat to really discuss in much detail is how does an attenuation tank work? So this is a frequently asked question that we get from time to time. So Lisa, take it away. How does an attenuation tank work?
It really is a very, very simple system, a very, very simple tank, essentially. It's used as a holding tank. So water will enter the tank. Usually by this point, it's gone through some filters, some silt traps to, try and clean it up as fast as possible. Maybe they went through some other SuDS elements, such as a rainwater harvesting system or tree pits. And so when it reaches the tank, this is, it comes in sometimes through multiple pipes, inlet pipes. So sometimes the water is just coming in via one manhole. Sometimes there's manholes dotted all around, depending on, the layout of the site. And sometimes the water from like channel drains and everything is also just going directly into the tank. So there can be multiple inlets, but usually there's only one outlet. So the water enters the tank through these various inlets and channels, and it basically is a void. It's a space for the water when it's flowing incredibly quickly, such as in a large storm event, to build up, to build up and fill, so as not to overwhelm the drains downstream. So the water will build up in the tank, and usually at the outlet manhole, which I mentioned, there's usually generally one outlet. There is something called a flow control device. There's different ways to do this. Sometimes for smaller tanks, it's as simple as a smaller orifice plate, a small hole. Water comes in through a large diameter pipe, goes out through a small diameter pipe, which will naturally slow the water out and allow the water to build up. But for some of the really, really big tanks to do, there's like proprietary systems called flow control devices, usually vortex flow controls, which essentially swirl the water and slow it down at a controlled rate. These are designed specifically to the tank because it depends on the tank height, the allowable discharge rate of the pipes downstream, which again will be different every site, depending on the size of those pipes. And the tank size is the tank size designed for all these factors, such as the allowable outflow rate, the volume of water that they predict will come in. They predict this by looking at things like rainfall for that area, traditional rainfall for that area. Obviously, the amount of surface water, which has been the surface area, rather, which has been paved over, which will create a runoff rate. Larger paved and built on areas will create larger areas of runoff. And also, they have to build in an element for climate change. Usually, something like 30 to 40% is added on top of this to take into account the fact that we're all going to the world's getting warmer and climate change is going to be a factor. So the tank is designed for all these things, so it should never really fill up. And if it's been designed properly, it should never completely. It should always be able to cope with any site, and the flow control has been designed properly. So that's how they work. It really is. It's as simple as that. It's a holding area for excess water, which will be allowed to discharge down the pipe at a rate the pipe can control. It can cope with. Yeah.
And you mentioned there just early on that with an attenuation tank, it can have multiple outlets and multiple inlets, and usually one outlet. Yeah. But it can be sometimes the case where the inlet and the outlet is the same pipe going in and out of the tank.
True, that is it's less common, but it is something called an offline attenuation tank. So the tanks, like I mentioned, which have inlets and outlets, are called online. So essentially that's because they're in a line, water comes in one side and goes out the other, they're in line. Something called an offline attenuation tank has one inlet and outlet, and it's designed as when the water is flowing at a really, really big rate through the pipes, they're usually kind of put somewhere mid-system, and they will just fill up. They will slow the water going down the pipe as well and fill up. And then once they're full, they will drain back out. And the storm event has passed, they will drain back out the same inlet that they come in. So yeah, that's called an offline attenuation tank because the water isn't flowing through. It's coming in and out again. But yeah, they're not as common as the online attenuation tanks. But yes, they are something that we see on drawings.
And with one way to identify with, say, an online tank, what the difference of an inlet and outlet is usually the height of the pipe and the location to the tank.
Sometimes for online and offline attenuation tanks, the inlet and outlet being the same hole, that will always be at the bottom of the tank. It will be the same. The pipe will be at the bottom. You have to understand, if you don't have the pipe at the bottom of the tank, it will not be able to drain out fully. For online attenuation tanks, the inlets are sometimes midway at the tank, top of the tank, sometimes even coming in on, on the kind of top surface of the tank. But the outlet, again, must always be right at the base of the tank. So that, it empties out completely. Otherwise, it'll fill up once and never drain out again. So you've essentially lost some of the volume of your attenuation tank.
In that case, it will then turn into a detention tank, and the fact that it will retain some water for reuse, not actually empty.
But then no one can access that, because unless it's been designed as such, then, that water will just stay there indefinitely.
And if you don't have the outlet at the bottom of the tank, once it does fill up, your then attenuation tank will be half full. Most of the time.
And then so for the next large storm event, you've lost that capacity for, the climate change, for the large storm event, for the rainfall, and you're opening yourself up to flood risk again, which defeats the purpose of the tank.
Perfect.
Yeah.
I think you summed that up very well. Thank you for that.
No problem. Thank you.